Hello guys, welcome back. This is the second video on Crash Course on Python.
Let's go!
As I have told you previously, variable is something that can store value. So how do we store values generally? Generally, we declare the data type and the name of the variable is equals to some value. This is the general syntax of defining a variable. But in Python, we just take the variable name and value. There's no semicolon, there's no data type. Yes, Python is very simple. Next, what are the rules for defining a variable? Can you give any name to a variable? Can you include characters, numbers, special characters, etc. in a variable name? No, you cannot include anything in a variable name. There are some rules you have to follow for declaring variable names. So the first rule is no special characters should be included in the variable name. Next, you shouldn't use a number at the beginning of the variable name. Next, maximum of 31 characters is allowed for a variable name. And the fourth one is we can use underscore at the beginning. Yes, there are no special characters to be used, but we can only use underscore at the beginning or also between the character name. Only underscore is a special character that we can use for variable names. Now, let's see practically how to define a variable. So open the Python programming environment I have shown in the previous video. So here let's declare a variable name and give some value to it. I have taken underscore, that is a special character in my variable name. Yes, it's valid. And I have also taken x is equals to 10. Also y is equals to 20. X and y are variables here. Even the variable name is a variable. All these three variables are holding some values, that is numbers. Now, what are keywords? Keywords are the reserved words in a programming language. That is, they are designed when the programming language is created itself, and we cannot use a keyword as a variable name or a function name or any other identifier. Keywords have some special meanings which they perform. So while using keywords, when we use keywords, they perform some specific task which they have been designed to do. So what are the keywords in Python? In Python, all these words are known as keywords. If you observe here, false and true and continue, or there are many keywords here. You'll know the meanings of these keywords in the coming videos. Don't worry about them. Now, I'll show you a way where you can practically see all the keywords in the current version of your Python in your system. Go to the Python console again and type import keyword, then print keyword .kw list. Now this print statement prints all the keywords existing in the keyword module of the Python. Now moving to data types. Data types are the values which fits into a variable. Defining variables generally, as I've told you already, we declare data type variable name is equals to value with a semicolon ending in many languages like C, Java, etc. So an example for this is float of x is equals to 20.45. Float is generally used when you want to declare a decimal value. But in Python, you needn't worry about the data types. That is, you need not worry about the float. You have to just give x is equals to some value. That is, variable is equals to value. X is equals to 20.45. Simple as that. Now, what are the different data types in Python? There are two types of data types, that is primitive and non-primitive. Primitive generally refers to built-in data types. That is, all the data types that come with Python when you have installed it. And non-primitive data types are generally user-defined data types. You have to define them. So built-in data types in Python are integer, string, boolean, float, and complex number. Integer is just some number without a decimal, and string is some set of characters, that is, you define any name, then it's a string. And boolean is true or false value, and float is a decimal number. Complex number is the same as in mathematics, that is 3 plus 5j, that is in terms of x plus yj. And these are all the non-primitive data types. We'll come to these in the data structures section. So now let's see the built-in data types practically. Go to the console again and let's check the type of x. It is class of int, that is integer. X is an integer. Now let's check the type of the variable 20. 20 is also an integer. And now let's declare x as x is equals to 20.0 and check the type of x. Now as it's decimal, it has come as float. You have to declare strings within a single quotation or a double quotations. So if you declare like that and check its type now, it is str. str refers to string. Let's check if we have given numbers to the strings in the quotations, what comes. So if you even declare numbers inside the quotations, then also it shows class str, that is string. If you declare anything in between quotation marks, then it is a string. Now we have seen data types. Now typecasting. What is typecasting? Typecasting generally refers to changing the data type. That is changing from one data type to another data type. For example, changing a number from int to float or float to int, etc. There are two types of typecastings. So the first one is implicit typecasting. Implicit typecasting generally occurs from a lower data type to a higher data type. This type of typecasting is generally taken by the compiler itself. There's no need for you to declare it or there's no need for you to change it. Then the second one is explicit typecasting. In this, there's also a possibility where you can change the data types from high to low also. Explicit typecasting has to be done by the programmer. So what is lower data type? What are higher data types? This seems confusing, right? So to clear the concept, let me show the hierarchy of the data types here. Here, integer is at the lowest circle. That is, it is a lower data type. And if you observe here, the float is here. This chart indicates that float is higher than int. So the smaller circles are the lower data types and the larger circles are the higher data types. So if you want to change data type from low to high, that is from int to float, that is called implicit typecasting. If you want to change a data type from float to int or from double to int, then it has to be done by the programmer explicitly in the program. Now let's see typecasting practically. So I'm declaring a variable x is equals to 10 and y is equals to 20.0, and I'm adding the two variables x plus y and storing it in other variable z. Now I'm checking the type of x, it is int. Then and also if you see here, type of z is float. Now if you observe in this example, firstly when we check the type of x, it was int, and now you have added x plus y and stored it in x again. Since y is 20.0, that is y is float, and you're adding a float variable to an integer variable, then the compiler automatically converts the lower data type into the higher data type, that is the data type x from int to float, and adds two float variables and store it in another float variable. So now implicitly by the compiler, x has been turned into the float. Now you may have the doubt, like why do we need to change the data type of x? Can't we add 10 plus 20.0? It is possible in our technical terms. It is generally possible when we do with our hands, but for the compiler, both the data types should be same for adding it. So different data types cannot be added. It implicitly converts x from int to float. Let's see some examples on explicit typecasting. X is equals to 10 and type of x is first int. Now let me change the type of x. Now x is equals to float of 20. We haven't declared it as a decimal number, but I'm using float. Now by using the above statement, 20 is an integer, but I have converted it into float. Also, x is equals to str of 20. It's a number. Yet, if you check the type of x here, it gives the result as string. This is possible when you use float and str when declaring the variable name before it. These are some functions used to convert the data types explicitly for a programmer.